So I would like to introduce our spotlight speaker for today, Emily Sheshelski. I'm almost positive I got it correct.
You got it.
All right. And she's with MicaSense, and I'm super excited to hear from her today. She's going to be sharing about the latest sensor development and the applications that MicaSense is being used, including forestry and agriculture and more. So, Emily, thank you very much for joining us. You want to start off? You can do a screen share. Tell us a little bit about how you got involved with it.
Cool. Yeah. So thanks, Desi. Excited to speak to everybody today. So my name is Emily Sheshelski. Like she mentioned, I'm a channel sales manager with MicaSense. So we're working primarily with resellers that can provide full systems to customers. So we're just the payload component. Then the customer needs to choose the drone and software that's right for them. So I'm managing our reseller network in North America and Western Europe. And I joined MicaSense over 4 years ago and didn't have experience with drones prior, had more experience in the agricultural space. So doing some audit work with a food retailer with their fruit, vegetable, floral growers. And so ended up taking the Part 107, doing some training with MicaSense, got experience through that. I don't personally fly as much now, so I'm more of like the educational piece of it, explaining the sensors and whatnot. And so that's kind of the backstory for me. And for the slides that I prepared today, I just wanted to provide a little bit of overview of like, what is multispectral imaging? What are some of the latest sensors we have and how they're being used? So that's what I'll share, and I'll share my screen now, but feel free as I go along to just ask questions as they come up. Like feel free to unmute yourself and we can have the discussion there. It doesn't have to wait until the end. So let's share here. All righty. So MicaSense, we're based out of Seattle. You can see our team there. We've got our offices here, and we also manufacture the sensors here. And we've been around since 2014, so it's been over 6 years now. The company was originally started by 3 aerospace engineers that saw that multispectral imaging with mapping with drones would be useful for commercial applications. So that's the reasoning behind the first red edge that they developed, which is that middle sensor you see there. It's got 5 lenses. And since then, we've expanded to provide 2 other sensors. So we've got 3 sensors in the product lineup. We've been refining our calibration component as well, which comes with all of the sensors. So that's really important for this kind of mapping work, to be able to calibrate for changing lighting conditions. And most recently, we were acquired by AgEagle in January. So we're now an AgEagle company. And as part of that family, we're going to continue to focus on making platform agnostic payloads. So that's something that's been important and a focus for us, both on the drone integration side, making sure that the sensors are as light as we can make them, low power pull, so that you can maximize flight time, as well as on the data processing side, keeping that open. So the formats for TIFF files are what is coming off the camera. And we keep those pretty open as far as working with third-party software so they can utilize the metadata and do a proper calibration. We've also got a GitHub. We have a lot of research customers that want to have like full control over their data and how the calibration process is done. They don't want a black box, so that's also an option. And then in addition to the sensors, we also have DJI integration kits. So you can see the Matrice 300 there with our dual camera setup, as well as we work with a variety of fixed wing drone manufacturers who do their custom integrations and add our sensors to their payload bays. So,
can I ask a question while we go to our next slide?
Yeah, go ahead.
So you were saying about the M300 and the drones that it can go on. What are some of the drones, unless you said we could ask questions as we go, right?
Yeah, definitely. Yeah, so we've the quick mount kits, or the integration kits we have for the sensors. work with the Gen 2 style, like gimbal mounts. So it's like, it works with the Inspire 2 as well as the full Matrice line. So yeah, Matrice 300 being the latest that we added a kit for. So it's actually the same components for mounting the camera across all those drone models. It's just a different light sensor mount. That's like the difference between the kits, depending on, Inspire 2 versus the Matrice, what that looks
Thank
like. Yeah. And then for fixed wings too, like Quantum Systems, they have a VTOL, their Trinity. They integrate all of our payloads. Wingtra and their Wingtra 1 integrates a couple.
High tech.
Their EBX. What was that?
High tech uses it.
Awesome.
Awesome. Yes, yes. Glad to hear that. Yeah. So a variety of them. But yeah, I was for the DJI ones, it's Inspire 2 and Matrice. And then, so what the multispectral sensor is actually doing is it's reading the light that's reflected back off of a crop canopy or any kind of vegetation canopy, really. So, the sun, this graphic is a good illustration of that. Basically, the sunlight that's beating down on the vegetation is either absorbed by the plant and used for photosynthesis, transmitted through the leaves, or reflected back up. And as you can see in the graph there, the majority of what's reflected is near infrared or non-visible light. So that's how the multispectral sensor is able to pick up on plant stress a lot more early on before there's visible signs of stress, is through that near infrared light. And this provides even more detail on that and how that's possible. So what we're looking at is a typical reflectance curve for a plant. So the green line there is what a healthy plant would typically reflect. So you see a bump in reflectance for green, and that's why we see it as green. Not as much reflectance for blue and red, and that's because the plant's absorbing that light and using it for photosynthesis. And then it jumps up in reflectance for near infrared. And so what'll happen if the plant is stressed, whether it's water stress, pest pressure, disease pressure, or nutrient deficiency, any of those things, that will start to affect how the plant is reflecting and absorbing light. So that's what we see with the dotted red line there. So we'll start to see more light reflected in blue and red, since the plant is not absorbing that and using it as effectively for photosynthesis, and a reduction in the light that's reflected for near infrared. And actually, before I go to that next one, what we're able to do with this, 5-band imagery, for instance, from Red Edge, we've got a blue band, green, red edge, which starts to be in that non-visible portion, and then a near infrared band. So using those 5, we can do composites. So like a RGB composite would just be the red, green, blue, and we could get the visual, like aerial view of the area we're looking at. You can create a false color composite. So that's a pretty interesting one too. And it's just you're taking the near infrared band and colorizing it as red so that we can see it. So any vegetation will show up as really bright pink if it's healthy, a more faded pink if it's not doing as well. And then it also helps to differentiate between soil. So soil will be a tan to a bluish tan color, depending on what kind of soil composition it is. And then in addition, you can create vegetation indices. So NDVI is probably the most popular, and that is looking at plant biomass. So it's especially good when you're looking at agricultural crops as they're growing. So earlier on in the growing season, before they've reached, kind of canopy maturity, it's a good one to identify any areas that are underperforming. And it's using the near infrared band and a red band and entering that into an equation to give you values from like 0 to 1. So 0 being soil, 1 being the healthiest, most robust canopy. So the dual camera system is one that I wanted to talk about more specifically. It's the newer offering that we have, and it's using the Red Edge sensor that I mentioned before, our original payload, and it's adding a second Red Edge MX Blue. So it's the 2 sensors, and they're rigidly mounted together. and there we synchronize the capture. So the reason we did that is to increase the spectral resolution, but allow an upgrade path for current customers. So if somebody has the red edge, they can just add this bracket and the blue camera. Or if somebody wants to start with red edge, that's primarily what they need. And then if a project comes up in the future where they need spectral resolution, more of it to do, species classification, they can upgrade. And so it has the standard, the Matrice 300 integration, like I mentioned before, works on the Inspire 2 also. And for fixed wing, the Quantum Systems Trinity has a payload bay for that. And so the 10 multispectral bands we're looking at for dual camera, they actually align with satellite, which is pretty interesting. So we've aligned it with Sentinel-2 and Landsat 8 specifically, since those are freely available, have been around for a while. A lot of research has already been done with those bands. So being able to, pull from some of those indices or whatnot that have already been used, and being able to offer a drone-based system that can get higher resolution and more frequent data capture. So it's a nice complement basically to the satellite. We've seen some people use it as if they're building out satellite models, like eventually they want to be looking at large areas and apply whatever analytics they generate to that. But they're really just starting with, grid-based ground truthing first. So being able to have the drone system is something to expand it before going up to the satellite level. And so at the high spatial resolution, correlate with ground truthing, then eventually scale up to satellite. Another way it can be used is for classification, like I mentioned. So it can be more broad, as in habitat mapping, or it can be more specific. So you're looking at like 2 different varieties of trees, for instance. So the first one I wanted to show is habitat mapping. And this one can be used, we've seen specifically looking at wetlands. There's been a lot of interest in wetland mapping. Really any kind of environmentally sensitive area or like managed public land where they want to be assessing year after year the composition of that area, whether it's if there's an initiative to establish more native plants and get rid of invasive species, or if it's just monitoring for extremely sensitive areas, monitoring effects of climate change. There's a couple of different reasons why we've had customers wanting to do this kind of habitat mapping. But this is a good kind of basic overview of how it's actually done. So this is a state park near us in Washington. So we flew with the dual camera over this area. It's right on the water, and we can see the RGB composite from the sensor here. So you can see it's mostly grassy area. We've got some trees and brush. There's some asphalt and parking lot area, and then the water at the very edge with a rocky beach and some driftwood that's washed up on the shore. And then this is NDRE, which is another vegetation index. So similar to NDVI in the formula, except we're swapping out the red band for the red edge band. So the red edge band starts to be in the non-visible light. And that one is more correlated with chlorophyll content in the plants. So it's good for assessing more mature kind of vegetation like this. It's to see more subtle variations in plant health. So you can see that with the grass. The healthiest is going to be blue, and the more moderate to low values are going to be in this area. The lowest values are red, so that's why we see asphalt is red. So is the water and the edge here. The brush shows up as lower values as well, dotted with the trees that have the higher values. So it's a good way to bring out more variation in the scene utilizing the vegetation index in this case. And then we can build the vectorized map for the habitat mapping, final product that we're looking for using that in the background. So we've had broader categories for this one just to illustrate how it works, but we've got grass and trees in green. Brush is in the brown color. Any kind of man-made asphalt areas are in gray. And then at the edge of the beach, you can see since it is a rocky beach, it's actually gravel that we're seeing there, as well as the timber, the washed up driftwood. So this would be something that, you could do at a more broad level, like these more broad categories, or if there's a specific species that wants to be investigated, you can do that as well. Just takes ground truthing efforts essentially to, first of all, identify, what is the unique spectral signature for this specific tree that we're looking at, and then validate with that with ground truthing efforts and build the map from there. And that since we do the lighting calibration for this allows it to be not just one snapshot in time, but something that you can compare from season to season or year to year to see any changes. And then another way to use it, this one is a forestry example. So this is, we see some more mature stands to the left. And then to the right is actually 3-year-old trees that were planted. So that's the area I wanted to kind of zoom in on. So this is the RGB composite from the dual camera system. And then we'll zoom into the 3-year-old trees here. So at this stage, they're still pretty small, but you can see that there's 2 different species here. So one is the darker green color and the other is the lighter green, and it looks like a little bit denser of a canopy than the first one. But at this stage, it can be very difficult, especially if you wanted to do a tree counting or just like assessing the composition between the 2 species can be difficult using the RGB at this stage because they're so small, but also because they are clumped together in certain areas. So that's an instance where the multispectral can be really useful. So this is a false color composite. We're taking one of the red edge bands from the dual camera and colorizing it. And so what we're able to do is differentiate a lot more easily between ground and tree, first of all. So like the ground is showing up as the bluish tan color. We can see the fallen timber, as well as the 2 different colors of orange for the tree. And then using that, we can create the vectorized map of, species 1 versus species 2. And I'll zoom into this area here. This is a good example of like the cluster that I'm talking about. So kind of difficult to discern what species 1 between species 2, even kind of zoomed in at this level. So utilizing the red edge band, there's more differentiation there. And we're able to clearly see that there's the 5 different stems for, species 1 clustered with species 2 in this area. So the other sensor I wanted to talk about is our Altum. And this is so it has the 5 multispectral bands, just like red edge, except it's a higher spatial resolution. So that's why you see the bigger lenses. And the red edge, for instance, if you fly at 400 feet, that would be 8 centimeters per pixel. And the Altum will be 5 centimeters per pixel at that same flight altitude. And then the lower you fly with these sensors too, the higher the spatial resolution will get, proportional to the flight altitude. So this one has been used for that reason a lot for child plot research. So different breeding trials, both for universities as well as companies that are either generating new seeds or new inputs. And so they want to assess application rate and different traits like, drought resistance and things like that. So we're able to get really high resolution imagery on each of those plots using the Altum as well as thermal information. So that's another thing that's kind of unique about this one. Have a FLIR lepton is integrated into the sensor and it's synchronized in the capture with the multispectral. So previous, we had some research customers that were flying red edge and a thermal sensor, but it was really difficult for them to align those 2 data sets in post-processing, in some cases impossible. And so that was something that we wanted to address with Altum, is able to get those multiple outputs and be able to view them side by side without having to do any alignment work in post-processing. And we've got a couple different integrations for Altum. You can see the different fixed wing integrations, the Matrice 300 as well. And in that photo in the top there too, with the Matrice 300, you can kind of tell more details on how we do our lighting calibration, which is important for multispectral. So in addition to the light sensor on the top, that's capturing like every time the camera is capturing, so about like once per second, and getting information not only on the irradiance, but calculating sun angle in relation to the drone. So that's why all of the sensor, we've got like 12 different sensors on there, and they're all at slightly different angles. In addition to the light sensor, we've also got a panel. So that's what's on the ground there. And so this white material here, we know the reflectance values for the, in this case, the 5 channels for the Altum, what they are here. So it's our reference basically. And you can take a picture of it before and after the flight, and using the panel shot and the light sensor, the processing software, whatever you use, like Pix4D or Agisoft, SimActive are kind of like the top 3. They'll automatically be able to use those bits of information to do the calibration. So a big way that Altum is being can be used more on the production agriculture side is for irrigation management. And there's kind of 2 different ways that can be used, both for planning out irrigation, using as additional, basically data that can be used when you're planning out how much to apply when, or if you're doing any kind of variable rate irrigation. And it can also be used to assess the, identify any leaks in the irrigation system too. So the first example I have is more on the planning side of things. This one is a mandarin orchard, and it's a pretty arid area that they're growing in. So they wanted to fly and assess crop water stress and start to use that as additional information before planning out irrigation. And what we can see with the temperature reading here, we've thresholded it out, so you're just looking at the canopy. And in general, even with multispectral imagery too, that's really helpful for the analysis piece, is to threshold out any soil. And you can do that by you can generally see like a histogram of the readings and section out the soil that way. You'll see a spike in values, for instance, for the vegetation. But what we see here with this final output is in blue. We see that a lot in the top here are the cooler canopy readings. And in the bottom, we see more of the slightly hotter readings, and that would be correlated with crop stress. And just through the visual analysis, I'm seeing like more of the reddish, orangish colors at the bottom here. But another way to assess it would be to threshold the values further. So that's what this is showing. So in this case, they took the thermal reading and they created a crop water stress index, which just takes into account the ambient temperature during the flight. So anything that's like above 2 degrees Celsius above ambient temperature would be high, towards 1 on the crop water stress index. And the highest values are what we see here. And it does correlate with the kind of lower area of the field that I circled before, as well as this additional row at the top. But this is information that was then used to provide, the farm manager or the agronomist, whoever is doing the scouting, to investigate further, to go to these specific rows. And in this case, it's a different kind of a soil type, more of a sandy loam soil in these areas. So what they ended up doing was increasing, they have a drip irrigation system for this orchard. So they increased the water pressure, a higher water pressure for these specific lines. To help address the water stress there, make sure the plant's able to utilize all the water that they're providing. And then another way to use the thermal is, like I mentioned, identifying any leaks or anything in the system. So whether it's a overhead sprayer, sprinkler, drip tape, like for the mandarin orchard, or in this case, they've got sprinkler pipes that they've laid down. And this is a lettuce field, so like newly planted. And shortly after water is applied, you'll be able to see anywhere where the water has been, it'll be cooler. So we've layered the thermal on top of the RGB composite here. So as you would expect, each, periodically, where there's a nozzle, there's going to be cooler readings. But we're not seeing that in this last row. So it does look like a partially clogged nozzle here and then fully clogged for these ones. So this is a zoomed in version of it. And then this is kind of zoomed out more. You can see across like a whole field, how that can be useful to just quickly assess areas at the top there, for instance, where water wasn't applied where it should have been. So it's an interesting way to utilize the thermal as for irrigation planning there. So that's all I've got prepared. I wanted to just go through the two sensors, like I mentioned, dual camera and Altum are our newer sensors and how they're being used. I think previously a lot of people tend to associate the multispectral with agriculture, but it's used a lot beyond that. And I'm seeing over the last year specifically more applications for kind of environmental monitoring. So I thought that would be fun to share some of those with the species classification and whatnot. So happy to open it up to any questions, if any questions came up.
Well, thank you. Thank you so much. And yes, it's opened up doors that we didn't even know were able to be done with this. So that's pretty exciting to see it in different realms. And you'd mentioned even floral. And so I went, oh, that would make sense, you know? So can you share a little bit about the workflow? Not everyone is familiar with the process. And so, you know, some people may be looking at those QR codes and go, huh?
Yeah. So the general process for the multispectral is, I would say, first of all, once the camera is powered up, it's generally connected to drone power. We've got a Wi-Fi interface that you can connect to with like a phone or a tablet. And that's got all the basic stats on that you're double checking before the flight. So it'll say, you know, GPS connection, is the light sensor connected on the top? Because that's important not only for the calibration, but also that's how we geotag the images. So there's like a GPS embedded in that. And how much storage capacity is left, because we've got everything is stored on an SD card, all the TIFF files from the flights. And then you'll set up the triggering mode from there. So generally the camera is triggering itself independent from the drone. So what we do is you'll set it up. Overlap mode is what we recommend. So 75% overlap is what you're wanting to do, as like a rule of thumb with this kind of mapping. And what the camera will do is once it reaches within a certain thing, it's like 50 feet of the desired, or 50 meters, something like that, of the desired flight altitude, it'll start capturing. So we do that to avoid having all of these pictures when you're, you know, getting to the desired altitude and when you're landing, to avoid those. We do have DJI has their Skyport integration. So in that case, it bypasses this connecting to the camera and having it, setting it up to trigger itself. So that's a little bit different. The Skyport does have drone communication as well as power. So you'll just pull up like GS Pro and you'll be able to say, okay, recognize payload, MicaSense red edge, and you'll be able to enter in your flight altitude and overlap. Everything will be set up from there. So it's the kind of the most streamlined workflow. And then after the flight, all of the TIFF files are stored on an SD card. And when you go to process, basically, in, you know, Pix4D or whatever photogrammetry software, the main thing to remember is just what were the lighting conditions during the flight. So if it's a sunny day, we just use the panel, for instance. And if it's a cloudy day, we use both the light sensor and the panel. Pix4D Fields has the most simplified workflow. So they just ask, like, was it sunny? Was it cloudy? And they'll pick automatically from there and utilize everything, which is kind of nice. And that's that kind of basic workflow. Once you get that, you'll get the GeoTIFF, the orthomosaic of the area that you mapped, and you'll be able to do some of the analytics. So RGB composite, some of the vegetation indices. Pix4D Fields, for instance, they have like pre-generated indices that you can choose from and look at. What we're starting to see more is companies that are specializing in the analytics portion. So like a good example of that would be Aerobotics. They're out of South Africa, but they've also expanded into the US, and they started with citrus and they've expanded to different tree fruit. They also do tree nuts, and they're offering the analytics specifically for that kind of crop. So they're saying, you know, based on our knowledge of multispectral and how to use the imagery, here's what indices we recommend looking at what points in the season. And they generate those without having to have somebody, an agronomist or somebody who can understand not only the field and the plant growth stages, but also interpretation of the multispectral. So I would say it's like some of it is researchers who are interpreting that. Some of it is, third-party software companies that have specialized in their analytics.
Well, great information. Thank you so, so much. Do you mind if I put your contact information into the chat there? And that way, if somebody has any questions or anything, they can circle back to you?
Definitely. Yeah, go ahead and share that.
I will go ahead and copy paste. And if anybody has any questions, let me put it to everybody. Hang on one second. And the information's in there. So that way, if anybody needed to reach out, had any other questions about it, kind of exciting, knowing just the possibilities and how we can plan ahead, know in advance. There's stressed plants in this area, very valuable tool. And so
yeah, as a targeted scouting tool, as like a more basic level, it's really interesting for that. Yeah, just like if you're looking at larger farms, to be able to target where an agronomist goes, or where they can do sampling even. Yeah, it's interesting. Yeah.
All right. Well, thank you so much. That kind of wraps it up.